quadratic equations by factoring them, by graphing them, by completing the square, and by using the quadratic formula. What we're going to do now in section 3 is we're going to look at applications of quadratic equations, and we're going to take a look at some story problems and see how we can use any of those methods to solve those. I will have to say to you that my preference is the quadratic formula unless I see something can be factored quickly. Now with your graphing calculator, that's also an easy method, but I can't illustrate the graphing calculator very easily for you on the videos, so I'm going to probably stick with those two methods. Completing the square is not used very often because it's a lengthy process, and it's the process of completing the square was necessary to come up with the quadratic formula, so it was the basis for the quadratic formula. Once we had the quadratic formula, we said, oh, let's use this all the time. The first problem I'd like to look at is number 2 in section 3 of your text. It reads, the width of a rectangular feedlot is 8 meters less than the length. The area is 20 square meters. Find the length and the width. Okay, again, read it to yourself. The width of a rectangular feedlot is 8 meters less than its length. Whenever they compare something to, let's say, the length, and I'm going to call this the long side, then I let x represent that, and then they said the width is 8 meters less, so I'll represent that side with an x minus 8. Now, what I'm going to do is I'm going to use what I know about solving or area for a rectangle, and that is that the area of a rectangle is found by taking length times width. So you know the area is 20, we'll plug that in there. The length is going to be the letter x, the width is x minus 8, and we've plugged those things into the equation for the area of a rectangle. Now all I need to do is to clean this up, and to solve it I have to get everything on one side. So first I'm going to get rid of the parentheses. And if you don't mind, at the same time I'm going to move this 20 on over to the right hand side and call it a minus 20. I'm just transposing. I could use the quadratic formula right now, and if I wanted to, then a would be 1, b would be a negative 8, and c would be a negative 20. I'm not going to choose to do that because I'm fairly certain that this factors, it does, into x minus 10 times x plus 2. And I know using the zero product rule that I will set those equal to 0, each of those binomials, each of those factors, and then I'll solve those for x. So right here I have x is equal to 10, and right here I have x is equal to a negative 2. Please remember you're looking to solve for the length and the width of a rectangle, so a negative value is not valid for this problem. So you should come back here and you should say to me that the length of this rectangle is equal to 10 meters, and that the width, which is equal to x minus 8, or 10 minus 8, the width is equal to 2 meters, and then you should just check that and see if their product, 10 times 2, is equal to the area, 20 square meters. And it is. Another application problem that might arise when you're solving quadratic equations, and it involves using the Pythagorean theorem as well. I'd like to look at number 8 in section 3 again. It's about a parking lot, and it says that the width of a rectangular parking lot is 51 feet less than its length, very similar to the last problem. Determine the dimensions of the parking lot if it measures 250 feet diagonally. All right. First of all, here's my parking lot and here's my diagonal. So I'm going to go ahead and put the 250 feet right here. It says that the width is 51 feet less than the length, so let's let x be the length and x minus 51 equal the width. And with that, given that I've got a right triangle here, let's use the Pythagorean theorem that says that if you take a leg and square it plus another leg and square it, that it should equal the hypotenuse squared. So what I'm going to do is I'm going to take this variable and square it, and I'm going to take this binomial and square it, and I'm going to let it equal the hypotenuse squared. I'm sorry, this should be a 51 right there. I'm going to multiply this out without showing the work. I've just got it written down here. You should think about, I will write this down for you. You should think about this as being x minus 51 times x minus 51. That's going to give you x squared minus 102x plus 51 times 51 is 2,601. And 250 squared is 62,500. Now, before I can solve this, one thing I do know is that it's a quadratic equation because it's got an x squared term. When you take the final exam, you're going to have to be thinking like that, that here's a quadratic equation that I want to solve. So this 1x squared and 1x squared is 2x squared. I've combined those terms. A minus 102x, it's a lone term. And then when I subtract 62,500 from this side, I have to subtract it right here. And what I get then is a minus 59,899. Now, this is the quadratic equation that you're going to work with, where you'll let a equal 2, and b equal a negative 102, and c equal a negative 59,889. I did a lot in the last video where we substituted those values into the quadratic formula. Again, remember the quadratic formula is the opposite of b, plus or minus the square root of b squared minus 4ac, all of that divided by 2a. I've written this in your weekly assignments, exaggerating that all of it is divided by 2a. I'm not going to put the numbers in. I'm going to tell you that this is what it will turn out to be. It will turn out to be that x is equal to 102 plus or minus, the value under the radical turns out to be 489,596. But when you take the square root of it, you get 699.7. And you're going to divide all of that by 2 times a, which is 4. And I'll just tell you that with a calculator, when you take 102 plus 699.7 and divide it by 4, you get a solution of 200.4. When you take 102 minus 699.7, you get a negative number. And you divide it by 4, you still get a negative number. And I don't care what that answer is, because it's no good. It doesn't work. This is an application. X represents the length of this parking lot. So it looks like it's going to be 200.4 feet. So I'm going to come over here and say that the length is 200.4 feet. And therefore, the width is 51 feet less than that. And that would give us 149.4 feet. Again, we could possibly check this using the Therian Theorem. We could just take these two squared, add them together, and then take their square root and make sure that they're equal to the hypotenuse of 250 feet. Let's take a look at another application involving quadratic equations. A little bit more difficult. This one involves the area of a picture frame. We are, again, going to be looking at the length and the width of that. Look at number 10 with me. It says the outside of a picture frame measures 14 inches by 20 inches. 160 square inches a picture shows. Find the width of the frame. Now, please, would you remember, excuse me, that the outside of the frame measures 14 by 20, but the frame takes up some dimension, an equal dimension all the way around, and lets you see 160 square inches of picture. That might mean that this is 16 by 10 inside here, and therefore 160 square inches, or any number of possibilities. That's just a thought. So here's our initial picture. And what I did is I copied the inside of this, the picture portion, off to the side, so that you could recognize that what we need to do is we need to work with this part because we know the area of that part. They gave us the area. So I have to write an expression here and here that will represent the length and the width of this frame, given that the overall, or the inside of the frame, the overall is 20 by 14. Let's start with this width right here. If the overall is 14, I have to take away x and x right here and shrink it down by that much on top and bottom. So I have to take 14 and subtract 2x to get an expression to represent the width of this frame. As far as this, I'm calling this a length because it's a longer side. Here I have 20 inches, but I got to take away, to get down to this dimension, this x and this x. So here I'm going to have 20 minus 2x. And I'm ready now to put these expressions into this equation and let it equal to 160. If you don't mind, I'm going to work with this backwards. And I'm going to say that 20 minus 2x, we'll call that the length, times 14 minus 2x, we'll call that the width, is equal to the 160, the area. Please don't do anything with that 160. I sometimes have people with a misunderstanding that because that reads inches squared, that they're supposed to square that number. That inches squared is the descriptor of the number. It represents the area of that shape. It means that it might have been, again, 16 inches by 10 inches. And when you multiply those together, you get 160 square inches. So nothing happens with that 2. It represents the area. Now I'm going to FOIL this. So this times this right here is 280. And then here I have a minus 40x. And here I have a minus 28x. And here I have a positive 4x squared equals the 160. Now I want to combine my like terms, and I want to get this quadratic equation in standard form. So I think what I'm going to do is 2 things right now in this step. I'm going to combine these 2 terms. That'll be a minus 68x. And I'm also going to subtract 160 from both sides of this equation. So what I'll have right here is 120. And then here a minus 68x plus 4x squared equals 0. And I'm going to flip-flop. I'm going to move all these terms so that they're in descending order. So I wanted the x squared term first, then the x, then the constant. Now I could go right to the quadratic formula. I could try to factor this. I could do any number of things. But you know what I happen to notice with this problem? This number right here is divisible by 4. So is this. So is this. And if I divide both sides of this equation by 4, and you can do this trick if you want to call it that, anytime you'd like with an equation. Here I'll have x squared minus 17x plus 30 equals 0. And I have an easier quadratic equation to look at. And actually, I think I recognize that I can factor this. I think I'm going to use x minus 15 times x minus 2. Let's just check. Negative 15 times negative 2 is positive 30. Yep, they add up. And so in one circumstance, x is equal to 15. In the other circumstance, x is equal to 2. Now let's see what makes sense here. Go back to the original picture frame. If I took this 20 inches and subtracted an x of 15 each time, I'd have nothing left. So while this number is not negative, it is not useful because it's not possible to have that happen. So the only answer for the width of this picture frame is for it to be 2 inches. So I would like you to just state for me that the width of the frame is 2 inches. You could also go back and check this. I'm not going to take the time, and I don't have the board space to do that, but as a result, and actually that doesn't take much now that I think about it, this dimension right here would be 14 minus 2 of these, or 4, so that would be a 10. And then this would be 20 minus 2 of these, or 16. So the picture is going to be 10 by 16, and that product is 160. The next application problem that I'd like to look at is a motion problem, one that involves the equation distance equals rate times time. Look with me, please, at number 26 in section 3. A turbojet flies 50 miles per hour faster than a superprop plane. That sentence right there gives you some information about the rate column. If a turbojet goes 2,000 miles in 3 hours less time than it takes the superprop to go 2,800 miles, find the speed of each plane. So we're looking to find the speed. We've read it. Let's go ahead and fill in the information again. I've gone ahead here and written that this row will represent the turbojet and this row will represent the superprop. So it says that the turbojet flies 50 miles per hour faster than the superprop. So the superprop is what I'm going to give just the letter R, and the turbo will be R plus 50. So there's our first sentence. If a turbojet goes 2,000 miles, and I think I'm going to deal with the time, the issue, 3 hours less time than it takes the superprop to go 2,800 miles, then find the speed of each plane. Now let's go back to the time thing. The turbojet goes 2,000 miles in 3 hours less time than this one. So let's let this be t, and let's let this be t minus 3. And now we've got our chart all set. Excuse me. So what you have to remember about this, and this is the difficult task here, is that the best way to solve one of these equations is to take this basic equation, distance equals rate times time, and solve it for either the rate or time since our variables are there. I'm going to go ahead and solve for r. So please remember, if d equals r times t, if I solve for r, then I'm going to be dividing both sides by t. So I want to take this divided by this. So 2,000 divided by t minus 3 equals, get this out of the way, 2,000 divided by t minus 3 equals r plus 50. That's from our first row of information. And here, 2800 divided by t, that's your distance divided by time, equals the rate from the second row's information. And now what I'm going to do is I'm going to take the more difficult row, this one right here, and I'm going to take the 2000 divided by t minus 3 and let it equal r plus 50. So I'm just recopying that. And then now, because I have an expression for r, and it's the same r as we used here, and r is equal to this 2800 divided by 2, then right here, by t, I'm sorry, I'm going to replace that with 2800 divided by t. And I now have an equation that has just t in it that needs to be solved. I don't believe that I'm going to go through this whole thing, but I'm going to try to do as much as I can. Again, it's board space, it's an issue, and I don't like chopping these up into two separate windows. I'm going to share with you or remind you that the least common denominator between these two denominators is t times t minus 3. So I'm going to multiply every one of these terms. I'm going to put parentheses around it so you can see me reminding you of that. I'm going to multiply every one of these by t times t minus 3. But I'm just going to kind of sneak them in because we've done this so much. This is the previous chapter. Oh, actually I think it's the chapter before that. But let's clean up the denominators. Take out the t minus 3s here. Take out this t and that t. So here I'm left with 2000t equals 2800 times t minus 3 plus 50t times t minus 3. And again, I got some cleaning up to do here. So right here I'll have 2800t minus 8400, and I'm just going to check, make sure I didn't make, yep, plus 50t squared, and this 50t times 3 is a minus 150t. All of that equals the 2000t. When I collect my like terms and get this 2000t over here, I'm just going to share with you that what I have left is 50t squared plus 2650t. Oops, and I might be copying that from the wrong spot. Let's, I'm just going to correct this real quick. Again, once it's all cleaned up, 50t squared plus 650t minus 8,400. All right, all of that equals 0. Like the problem we did just a bit ago, I could divide every one of those by 50. And I would have a simpler problem to work with. And if I divide this by 50, I'll have t squared. If I divide this by 50, I'm going to have 13t. If I divide this by 50, I'm going to have a minus 168. And I'm going to find out, after I decide to factor both sides, I guess I'll finish that up real quick. It turns out to be t plus 21 times t minus 8 equals 0. And so one of my solutions is a negative 21 here, and the other solution here is 8. I'm not showing you all the steps there. This is the only viable solution. I can't have time that's negative. And then last thing I need to do is I need to plug t of 8 into one of these two equations. Easiest to plug it into this one. And when I take 2800 and divide it by t, I'm going to get the rate for the superprop, and that is 350 miles per hour. So R for, I guess I'm going to put that right here. R is 350 miles per hour. And then R plus 50, of course, is 400 miles per hour. That'll be for the turbo. And again, I got the 350 by taking 2800 and dividing it by 8. Here's my solutions. Quite a bit of work to get here. This is one of the most difficult problems in terms of solving a quadratic equation. And having to work with a rational equation, which is previous work, and then solving the quadratic. And then finally, here I solved for t, and I really wanted to solve for r, so I had to go back to the original equations and get my values for r. In the application sections of solving quadratic formulas, we also ask you to take a formula and rearrange it for a different letter. Or, again, reproduce or change that equation. Sometimes we say solving a literal equation is what we say. I want to take this equation and I want to solve it for s. Well, if I want to solve it for s, then I better get the s squared term alone. So I'm going to think about that first. So when I have a fraction in front of here, I'm going to first multiply both sides, and I'm going to write that as 3 over 1. So you see that I'm multiplying by the reciprocal. Well, if I do that, then I better multiply that v by 3 over 1. I don't need to show that but 1 there, but some people that really helps them. So I have a 3v now. I'm going to get rid of that 1. These 3's cancel out, and what I have is s squared divided by h. Again, I'm looking to solve for s, so let's get that s squared alone. So let's divide both sides by h now, and now things are looking pretty clean. And so I have s squared equals 3v divided by h. And to solve by s, all I do is take the square root of both sides. And I find out that s is equal to the square root of 3v divided by h. There are circumstances like this when I have to rearrange an equation where I may even have to use the quadratic formula. So I'm going to do that next in the next application. It's a little bit more challenging. Here I just use the principle of roots. In this equation, I want to solve for r. My dilemma is that on the right-hand side of the equation, I have a term that's got r squared in it, and also I have a term that has r in it. That being the case, I have a quadratic equation. I have something r squared plus something r. So I have the first two terms in descending order of the exponent, if you will. I'm going to solve this by the quadratic formula, but I've got to have 0 on one side. So this has got to be put into standard form. So what I'm going to do is I'm going to move the a here over to the right-hand side, and I'm going to keep this in order. R squared term first. I'm going to write this as pi sr. I want that r factor to be last, and then minus a. Would you try to pretend that this reads 2r squared plus 10r minus 15? Now I just threw numbers out. 10, 15, it doesn't matter what. I just need you to think of what's in front of the r squared as a number. Think of what's in front of the r as a number. Think of that as the constant. And now what I'm going to do is I'm going to use the quadratic formula, and what's in front of r squared is pi. And what's in front of the r term, or the x term, is pi s. And the constant here is a negative a. It's the whole thing, remember, the constant is. And I'm going to put these values into the quadratic formula. The quadratic formula says to take the opposite of b. Well, here's b. So I want a minus pi s. Then it says plus or minus the square root of. It says take this b value and square it. So I'll have a pi squared s squared when I square that, minus 4 times a, which is pi, times c, which is a negative a, all divided by 2 times a, which is pi. And I'm just going to clean this up a little bit. There's not much to be done. The solution for this, and I really shouldn't have used the letter x here. I should say to you that the solution is for the letter r here. So r is equal to, we've always been using x, a negative pi divided by s, plus or minus the square root of pi squared s squared. This minus times this minus is a positive 4 pi a, all divided by 2 pi, and I'm done. I have a new equation. I have taken the original and I have solved that for r. Please remember that when you solve an equation for a letter, you can't have the letter in its solution. So r can only be on this side. Everything else has to be letters other than r. So I had no other means to do this other than to use the quadratic formula.